with y'all, boys, man? What's up with y'all? How y'all doing? How y'all doing today? How y'all doing today, man? Happy Sunday. What's up with you guys, man? Hope you're having a great day so far. So, today, just put this in here, pin this. Okay, guys. How you guys doing? How you guys doing? Hope you guys are doing well. Hope you guys are doing well. So, today, the game plan for today. So, first, yesterday we started solving twosome and we did the naive approach for twosome, which is the n squared solution. Now, today we're going to try to go over the semi-optimal solution of twosome and then the optimal solution as well. And afterwards, we have more problems to do. So right now we have these slightly harder beginner set. Then we have some recursion, okay, some recursion problems. And finally, we have some bit manipulation problems. So first off, we're gonna do the slightly harder beginner ones. Then we are gonna then if we have time, we're gonna move on to some recursion and then bit manipulation, but probably we won't be able to get to that point. So yeah, that's the game plan for today. Make sure that you guys like the stream and subscribe, and let's get started. So we yesterday we already solved twosome with the naive approach. So right now we're gonna do twosome semi-optimal. Semi-optimal. We're gonna have, of course, our inputs array, and we're gonna have our target. We're gonna have our target. So the semi-optimal approach is the following. We have to do the following. First, we gotta sort the array. Then we're gonna have two pointers at the beginning and end of the array. If the if the value which gets depicted from the sum of the two pointers is equal to target, we are going to return the indices which the two pointers point to. Otherwise, if the target is greater than the sum of the values which are at the two pointers, we're going to decrement the right pointer. And if the target is smaller than if the target is smaller than the sum of the two values, we're going to increment the left pointer, because from the left coming up, going to the right, we increase the values, and from the right going to the left, or maybe this is the left for you guys, from the right going to the left, we we decrease the values, because yeah, that's because the array is sorted. So first we gotta what we're gonna do is sort the array like this. And always, guys, it's best to use built-in functions when you can, because writing your own algorithms from scratch is usually more complicated and it's gonna take you more time. And usually in a contest or in an interview, you don't have that much time, so you gotta make the best with your time. You gotta make the best with your time. So yeah. Okay, first we sort the array. Then we have a pointer which is left is equals to 0, and right which is equal to the size of the array minus 1. So the last index. Now, while left is less than equal to right, if actually this is not an int, it's a vector. We're gonna return an array with two values in it. So array if array of left plus array of right is equal to the target, we are just gonna return the. And now, I might be wrong on this approach. I am not completely sure this is how you do it. I have pulled up an article right here of the of a solution. So we're gonna go through the article as well. But first, we're gonna try to solve it by ourselves, and then we're gonna go to the article explaining the problem. So right here, we're gonna return left and right, which are the indices. Else, if r of left plus r of right is greater than target. So what this means is greater than target. So what we have to do is we have to decrement right, minus minus. And else we just have to increment left. And if we don't find anything, we're just gonna return -1 and -1 because we haven't found the indices which add up to target, okay? So the input array is this. So we're gonna see out, okay, no, actually vector of int is gonna be this, and the target is 9, right? Yeah, the target is 9, so right now we're gonna say for int index in to some semi-optimal of r and target, we are going to see out index with a space, and let's see if this gives us the correct output. Okay, we wrote an if here accidentally. Okay, I was not declaring this scope. Okay, I misspelled target. Okay, we get 0 and 1. Okay, let's try something else. Let's try what is 18? So we should get 1 and 2. Should get 1 and 2. Perfect. Let's try 17. We should get 0, 1, 2, 3, 0 and 3. 0 and 3. Okay, let's try to go to lead code and submit this. Let's try to go to lead code and submit this. I don't know why, but I submitted this exact same solution and lead code did not accept it. So let's see if we have more luck now. So this is an O of n squared. No, this is an O of n log n solution. So it's faster than n squared. It's more optimal than the completely naive solution, because in the completely naive solution you use two nested for loops, and that is O of n squared. This is O of n log n. So if we do space complexity chart, we can see we have this very nice chart from Free Code Camp. Where is it? Where is it? Okay, here it is. So we have, what the heck, I open image in new tab. Okay, we can just, okay, so we get this. This is our, so as we can see right here. So as we can see, O of n log n is more optimal than O of n squared, which is horrible. But O of n log n is still bad. It says O of n is fair, and then these ones are good. So the most optimal solution for this is gonna take O of n, which is gonna be, which we're gonna have to use a map for that. I'm gonna try to do that by myself, and then afterwards, if I can't, I'm gonna go to the article. But first, let's submit to lead code. Submit to lead. Oh, and also another thing we need to check is that left should not equal right. I think. Yes, left should not equal right. Now that is probably why the last submission I made did not get accepted. Because I'm pretty sure it didn't include that. Okay, so we have sort, but this is nums. Nums. Just replace all of these like this. Okay, let's see if we get submitted right now. Okay, we don't. So we get 0 and 2 first. Okay, I have no idea why this happens. No idea. No idea. So let's get this. There is definitely something here. Approach has 2.0, but there's a major issue. After sorting, the indices no longer correspond to the original array positions. What? Really? Nose begin, nose end. The original array positions. After sorting 2, 3, 4. 2, 3, 4. Oh, okay. So, don't respond to the original array positions. You can fix by sorting the original indices before sorting. Sorting the original indices. There's a push back. All of n log n. Okay, let's see this. Let's see this all of n squared. Yeah. Okay. So let's say to sum of n log n solution article. C++. Okay, but I don't get it why when we sort. Okay, let's see out numbers of left and numbers of right. Numbers of left and numbers of right, so we get 2 and 4. 2 and 4. It should be 2, 3, 4. Oh, okay, I get it. So basically, when we sort it, so this should be 1 and 2, right? Yeah, this should be 1 and 2. And when we sort it, 2 goes to position 0, and 4 still stays in position 2. Okay, so that's basically why that doesn't work. That's basically why that doesn't work. So, hmm, we need to find the position in the original array. The position in the original array. Okay, what if I use a map of intent and then I for int n in nums, I do m of n. Actually, no, I'm gonna need a for loop and I get 0, I less than uh nums dot size I plus plus m of nums of I is equal to I. And like this, we're gonna have each numbered index. So okay, now I equal to not equal, right? We're going to return m of nums of left and m of nums of right. All right, I think. Okay, third case is false. Third case is false. Okay, that is not correct. So it's 0 and 1. Okay, so the problem is that there's only one entry in the map for this. There's only one entry in the map right now, and that is 1. That is 1. Okay, I guess so we really do need to make some sort of um, okay, let's just see the solution. So we already know the naive approach. Binary search. Okay, we're gonna check sorting and two-pointer technique. The idea is to use the two-pointer technique, but for using the two-pointer technique, the array must be sorted. Once the array is sorted, then we can use this approach by keeping one pointer at the beginning and one pointer at the end of the array. Check the sum of the elements of these two pointers. Sum equals the target, we found a pair. Sum is less than target, to move left pointer to the right. If sum is greater than target, move right pointer to the left. No, this approach is the best approach for a sorted array, but if the array is not sorted, okay. Just, but if the array is not sorted, then we use the below approach. Just for a sorted array. If the array is not sorted, we use the below approach. Two-point technique, we make sure the array is sorted. Okay, but we have to return the indices of the elements where they are placed in the original array. So I think it is really how to use a pair with this. Hmm. So how to have duplicate values in map C++. Duplicate pairs. Array to move to map values with the same key. Okay. Let's see. Same key. Hmm. Okay, so this approach would work for to some to some to some 2 where the input array to some 2 input array sorter. Why is this medium? Okay, and this should get submitted. Yeah, and as we can see, this one is pretty much straightforward. So the input array sorted and it's sorted. So unlike the two sum one, here we don't need to find the value in the original array, the index of the value in the unsorted array. Hmm. Okay, so hmm. Okay, so what we want is when you do 3 and 3, and when we put in 6, we want to get 0 and 1. We want to get 0 and 1, but right now, what do we get? We do get 0 and 1. What? Huh? Am I missing something? Okay, we do get this, but if it's 3, 2, 4, we're gonna get 1 and 2. 0 and 2. Okay. Okay, let's check this solution using hash set. Okay, let's read the optimal solution for now. So, brute force way, we did the brute force. Okay, optimal. Here's where we start thinking like problem solvers. Instead of checking all pairs, we use the complement trick. If n nums plus nums of I plus nums of j equals target, then nums of j equals target minus nums of I. So let's say the number we're looking for, nums of j, is called the complement of nums of I. Complement of nums of I. Instead of searching the whole array for that complement, we can remember the numbers we've already seen in a fast lookup data structure. Searching the whole array for the complement for this. And Pascal data structure. In C++ is a hash table key. What we search for. Here the number itself value. What do we store alongside it? Here the index of that number. Lookups and insertions of oral 1. Okay, so I'm gonna map number index nums dot size complement equals target minus nums of I. They were already set a complement. If mp dot count complement return okay, mp remember, okay. Let's say this is 2 and 3, it's equal to 5. So 3 is equal to 5 minus 2, that's correct. Math complement explained. Math minus a complement value set that completes a whole. Complement of A. Okay, it's not this. Okay. Complement this. Target minus nums of I. Okay, so let's do this solution. So vector int to some optimal. We're gonna have our vector r and then an int n. No, that's target. Okay, so we're gonna have a map. Doesn't need to be a word for int I get 0 less than r dot size I plus plus if complement is equal to target minus r of I. So if m of complement, so basically f m of complement. Okay, I'm gonna dry run this. Return complement and I. So this is basically R of J. So this is J complement. We're gonna return M of cannot like this, M of complement and I. Then we're gonna say M of complement. What are we add? So this is an index, okay? So what are we gonna add? MP of nums of I. M of nums I is equal to I. And then return an empty right here. Okay, it's not. Okay, actually, I should rename it. R nums. Okay, there we go. Okay, 1 and 2. Yes, 1 and 2. Okay, so let's dry run this. So let us see out complement. So we're gonna see out complement. We're gonna see out target. See out complement. See out target. And also see out nums of nums of I nums of I. Okay, and then here we're going to see out, okay, put in end line. Then here we're gonna see out here we're gonna see out and okay, so I gonna see out again numbers of I. Again, we're gonna see out numbers of I, and then we're gonna see out I like this. Let's see. Okay, so first complement, okay, target, okay, space here. Okay, complement is, so target is 6, nums of 0 is 3. So then the complement is 3. Okay, so do we have 3 as an entry in the hash map? No, we don't have 3 as an entry. So if we had 3 as an entry in the hash map, we would have had the the index 0 as an entry. So we don't have it, so we add 3. So this is 3 with index this is 3 with index 0. Okay, so second loop, now this is 1. So right now 36, so now this is gonna be 4. Yeah, complement is gonna be 4. 36, number of I is 1 exactly. So is M of 4 inside of the map? If it was, we would have returned M of 4, which is 1 and 1. Okay, let's let's see out p dot first, p dot second, just to make things even clearer. Okay, so okay, set map before adding new complement and index. And and then this, and now it's gonna be map after adding new complement and the index. Okay. Okay, so first the complement is 3, target is 6, where it's index 0, which is 3. So basically right now we have nothing inside the map. So the complement is C is equal to 3, target is equal to 6, nums of 0 is equal to 3, right? Hello, Somik. So basically, you can learn from YouTube. You can learn from articles. You can learn from whichever one is best for you. If you're a visual type of learner, I'd suggest YouTube. If you're more into reading, maybe articles. What I'm using to learn is YouTube and articles and stuff like that. So basically, yeah, that's what I'm doing to learn. And books are also a good resource, I would say. It's whatever works best for you. Whatever works best for you. Okay, so uh, where was I? Okay, so first map is empty. Map after adding new complement and index. So we add 3 with index 0. Okay, so now actually we can even add iteration number I, iteration number I, for even more. Iteration number 0. So for iteration number 0, complement is 3 because target is 6 and number of 0 is 3. So do we have this in the map? If we do, we're going to return the index which this complement has with the current index, which is 0. But we don't. So we're going to add it to the map. And now the map consists of 3 with index 0. 3 is a complement of target minus nums of 0, which is 3. Now we have iteration number 1. So, no problem, bro. You're welcome. You're welcome, bro. No problem. So then we have iteration number 1. Now complement is 4, target is 6. Number 1 is 2. So map before adding complement and index is this. And then numbers of 1 is 2. Yes. Map after adding new complement and index. So we got 2, 1. Where did this 4 come from? What the heck? Shouldn't it be just iteration number 2? Complements 2, target 6, num 0. Nums 2 come map before adding new complement and index. Okay. Okay, let's access the AI. It for to get added in the map here. Where are you from, bro? Hello, Imeriash. I am from Bulgaria, bro. Where are you from? Where are you from, man? I am from Eastern Europe. Eastern Europe. X is the value for the key. The key does not decrease with default value. So during iteration 1, nums2, nums1 of 2 complement 4, your map currently contains 3 of 0. Then this line runs. Since it does not exist, the map automatically inserts. Does not exist. Let's see, to be adding two trees in map. So the map on iteration when I is wait, when I is 1, but after iterations it seems it is adding one entry. Uh, I am in my final year. I'm in my final year of university, bro. So I'm in my final year of university. I'm not really targeting any company. Pretty much, I don't care where I'm gonna work. I just want to work somewhere. And the roadmap which I am following is the roadmap which I am following is I follow Striver, I follow Take You Forward, I follow Algomaster, I follow Kunal Kushwaha, and I also follow uh, the ultimate topic list. The ultimate topic list. That's what I'm following. Uh, and you, bro, which year are you? Which company are you targeting? And what roadmap are you following, bro? I would be very interested to know. Okay, an accidental insertion from the normal insertion from accidental insertion. Two different insertions happens. Two different insertions happen. Accidental insertion. This factor keep iteration 0. Number 0 is strict. Complement is this. Map position empty. This line runs. Strict analytics maps inserts. Yes. The later nums of I, m of nums of I is equal to I. Becomes m of 3 equal to 0, but 3 already exists. So it just overwrites the same value. Result, only one visible entry was added. Iteration 1. Nums1 equals 2, complement 4. Okay, current map. This line runs. Since 4 does not exist, map inserts 40. Now map is 3040. Then later M2. Okay, y'all, I'm gonna have to watch a video tutorial on this later. Think I'm gonna move on. I'm gonna move on to the next. Oh, thank you all so much for. Thank you guys so much for 30 views. So I'm gonna move on to the next problem. Next problem is check anagram. Check anagram is next. So so since silent true. What is an anagram? A word phrase from arranging the letters of another word phrase. So yeah, basically we can solve this by using a map. So let's see, bool is anagram string A string B. We're gonna say map of chart int mem A, and then map of chart int mb. Then for char c in A, we're gonna do ma of c plus plus. Then for char b, for char c and b, gonna do mb plus plus. So if m of a dot size, we can do that, right? Plus plus map size. Yeah, okay. So it does not equal m of b dot size. This is obviously not going to be anagrams since they don't have the same amount of letters. So, and otherwise for auto, so p m of a m of a p m of a. Okay, so we got these, we got the maps. If p dot first a for auto p p1 of b, if p dot first does not equal, if p dot, okay, how do you, okay, we have two maps, okay, I think we can just, can we just for char c and a, if m of a of c does not equal m of b of c, return false, else we're going to return true. Okay, this should work because we're going through the characters and we have the characters in the maps. So we have in M of A, we have each character from the string A counted with a count, and then in M of B, we have each character in string B with a count as well. And so we iterate through A, and if the count uh, for M of A is not the same for M of B, we return false. So let's see if this works. A equals silent and string B equals listen. Okay, this should give true. So is anagram A and B, and this should give us This should give us 1. Okay, we get 1. Now let's see. Let's say we have two n's, 0. Let's say we have a t in here. Okay, 0. Let's see if we have ABC and then we have CAB or something. This should give us true. Okay. Alright, this seems to work. Okay. So this is, I think, the optimal approach. We use O of n space because we create two maps, but we use O of n time because we only loop n times to this stuff. Hello, dude. I'm from USA NYC. Hello, hello Anurad. Hello Anurad. Welcome to the stream, bro. Welcome to the stream. How are you? How are you? Damn. Well, currently working at Microsoft as a senior tester. Congratulations, congratulations, congratulations. That's how. What did you do to prepare for the interview at Microsoft? Are you an intern? No, I'm not an intern. I'm a student. I'm a student. I'm a student. Okay. Hmm. So yeah, I think we did this one. Okay, this is one of the approaches. So for sorting, so let's see, what is an anagram? A word or phrase form arranging the letters of a different word or phrase or the original letters exactly once. Letters exactly once. Okay, so what this, okay. Yeah, we're still using them once. So we still get 1. Okay. Give me some test strings to check my is and function works. So give what the result of each test case should be and don't give that many. Okay, so listen and silent, listen and silent. Okay. Hello and world and world. Okay, we're studying. I am studying at the University of Ruse. I'm studying at the University of Ruse in my city in Bulgaria. I am studying in the east where I live. This should be false. Should be 0. All right. Apple and PayPal. So it should be true. Yes. Okay. Space is ignored. So we need to ignore spaces. Elegant man. I mean, it still gives true. True if case sensitive, false if case insensitive. So it's case sensitive, so it should be false. Oh wait. True if true if case insensitive, so it is true. Really? So you're in Microsoft, how you get, yeah, that's what I want to figure out what you did to get into Microsoft. So from my interview, there's nothing special. The basics must be strong, like data-driven qualities, collaboration, growth mindset. These are some factors on which they focus. Okay. And what type of how difficult were the problems with? Oh wait a second. So senior tester. Did they ask you any DSA questions? And if yes, how difficult were they? Is a question I have. A and B, so empty and empty should be true. Okay, and then A and B should be false. A and B should be false. Okay, zero. Okay. All right. Question map or sorting. Okay, guys, let's try to solve this with sorting as well. And then I'm gonna call it a stream after that because we've already been streaming kind of for 1 hour. So, like, I'm not good at study. I haven't got good marks, so I can't make a good college with CS. Which type of questions? Uh, he is asking any DSA question. Yeah, I'm asking if they asked you any DSA questions, and if yes, how difficult were they? I mean, you don't need. It's okay, bro. You don't need to be in a good college in order to land like a good position, though. You just need to be good at coding. So we're gonna have string A and string B. Then we're gonna sort A dot begin, B dot A dot end, sort B dot begin, B dot end. So if A dot length does not equal B dot length, we're gonna return false. Otherwise, we're going to for int I get 0, I less than a dot length, I plus plus. If a of I does not equal b of I, we are going to return false, and then we're going to return true here. Okay, so let's try is anagram 2. So this should give false. Okay, gives false. How hard was DSA question? Yeah. Was it like a lead code easy? Was it a lead code medium? Was it a lead code hard? Okay, let's try other test cases. A gentleman. So guys, this solution is, it doesn't use any extra space, but uh, it is slower when it comes to time complexity because we are sorting the strings, and basically that is gonna take all of n log n. So this is a little slower in space complexity wise. No, not space complexity, time complexity. A gentleman, elegant man, elegant man. This should give true or one. This should give one. Okay. Okay, we're gonna try one more. Listen and silent. Listen, silent. Listen and silent. You should give one, and let's try one more. This one. Let's try this one. I actually missed this one when checking the other function. This should give false. Okay, zero. Okay. Wait, I missed some stuff. Hold up, let me. How hard was this? I think we should make our own software or any applications so that they'll know, or everybody rush for DSA. I watch my video, everyone go ask like from graph most important sorting. Basically practice like 150 lead code problems on arrays and strings and trees and graphs dynamic programming, and that were not too hard. They just focus on how you think and optimize. So, okay. Okay, man. Okay, man. All right, you guys. I mean, that is gonna be pretty much it for today. Uh, Thank you guys for tuning in. We can practice mock interview on prompt. We're interviewing IO, etc. Focus on trees and arrays. They come up the most. Okay, Anurad. Thank you, bro. Thank you, bro. Thank you for helping out. Okay, guys. Thank you guys so much for tuning in today. This is gonna be it for today. Yeah. We will be back tomorrow at the same time, 5 p.m. EEST time. That is 5 p.m. EEST time. I stream every day at that time. See you, buddy. Goodbye, Zertonic Gaming. Thanks for tuning in. And yeah, that's basically it. And have a good one. And I'll see you all tomorrow. Peace out.